Hello everyone. Today's video is going to be a pipe embedded in non-cohesive ground and how to calculate the axial load carrying capacity of a single pipe. So let's say this is a single pipe. Which is embedded into non-cohesive ground. That means C equal to 0 and pi is not equal to 0. It is always greater than 0. So non-cohesive bed like sandy ground, it could be non-cohesive. And we need to find out the axial load carrying capacity, the ultimate load carrying capacity of this pipe. So how will you calculate it? Let's see the load transfer mechanism. When you apply the vertical load, it is being resisted by the ground by unit skin friction. Acting like this, and also unit end bearing resistance. So unit skin friction is Fs, unit end bearing resistance is Qe. So if you want to find out for this part the ultimate load carrying capacity of this single pipe, then it will be the unit skin friction Fs multiplied by the shaft area plus unit end bearing resistance multiplied by the area of the pipe at its tip or at its end. So there is the equation, famous equation, to calculate the ultimate load carrying capacity of a pipe. Now, this Fs and Qe will depend upon, this is the function of nature of the soil. Nature of the soil. So what is the nature of the soil? It is non-cohesive. It is not cohesive. So it is non-cohesive. So for non-cohesive soil mass, how will you calculate the unit skin friction? The unit skin friction is calculated by the formula which is K times sigma V prime into tan delta, where K is called coefficient of our pressure and sigma V prime is effective vertical pressure at a particular depth Z, and delta is the angle of wall friction, angle of wall friction, right? So if you go from the ground level to a depth Z from the ground level, what is the vertical pressure at this plane? The vertical pressure, effective vertical pressure, you can find it out what it will be. The effective vertical pressure, sigma V prime, will be the effective unit weight. So you should know the ground properties. So ground properties, here the unit weight, effective unit weight is gamma prime. So this effective unit weight multiplied by the depth will give you the effective vertical pressure. And gamma prime is the soil property which you can find it out. So effective unit weight multiplied by Z equal to the effective vertical pressure. This vertical pressure, when you multiply it by K, this becomes effective horizontal pressure, where K is the coefficient of earth pressure, which is defined as horizontal pressure upon vertical pressure. So coefficient of earth pressure is defined as horizontal pressure divided by vertical pressure. Therefore, horizontal pressure at this point, at this location, is the effective horizontal pressure. Sigma h prime, K into sigma v prime. Now, if you multiply it by mu, mu is here tan delta, then that becomes the unit skin friction Fs. So this sigma h prime into tan delta is called unit skin friction, and therefore the formula is given over here. K into sigma v prime, sigma h prime into tan delta. So delta, how will you find out? Depending upon the roughness of the surface, you can find out the value of delta, and the value is going to vary from 2/3 of angle of friction phi to maximum value would be phi. If the surface is very rough, delta value can be taken as phi. If the surface is little smoother, you can go to the lower side, that is 2/3 of phi. And therefore, you are in a position to calculate the unit skin friction. So the final expression for unit skin friction is Fs equal to K sigma v prime and delta. Now what is the vertical pressure? Vertical pressure, as you know, is gamma prime into Z into tan theta. Right? Now, if Z is 0, Fs value will be 0. So Fs will be 0 at the ground level. It will be 0 at the ground level. As you go down, Z value increases. So Fs value will also increase. As Z increases, Fs also increases. And at a particular depth, Fs becomes maximum. So it increases like this. The value of Fs is going to increase linearly as Z increases, because for the given soil mass K is constant, gamma prime is constant, delta is constant, so Fs depends upon Z. So Z increases, Fs also increases, and it becomes maximum at a particular depth. So this is the locus of unit skin friction. So here at this depth the value of Fs becomes Fs max, and the depth at which Fs becomes maximum is called critical depth. So this depth is called critical depth. Therefore, the depth at which Fs equal to Fs max, that depth is called critical depth. Jet critical. That depth is called critical depth. So here Fs becomes maximum and that depth is called the critical depth. Therefore, Fs max, the maximum unit skin friction magnitude will be K into gamma prime, replace Z by Z critical, into tan delta. And beyond Z critical, for this depth, L minus total length is L, the total length of the pipe is L. So for L minus Z critical, the value remains same. So it remains Fs max. So the concept of Z critical, you have understood it. Now, if you want to find out the skin friction, so the skin friction Qs will be up to depth Z critical, it is going to linearly vary and achieving the maximum depth. So Qs1 up to Z critical, this is up to Z critical plus beyond Z critical, that skin friction is called Qs2, that is beyond Z critical. So for this length L minus Z critical, it is the skin friction is Qs2. Above this it is Qs1. So you can calculate the magnitude of the skin friction. Therefore, the total skin friction will be equal to Qs1. It is 0 here, plus what is the value of Fs here? It is going to be Fs max. So take the average divided by 2 multiplied by the shaft area As1, that is up to Z critical, whatever is the shaft surface area is taken as this one, plus Qs2 is going to be for the remaining depth, and for the remaining depth the skin friction is going to be Fs max, so it is going to be Fs max multiplied by area beyond Z critical is As2, so it will be As2. So we can say therefore the total skin friction is 0.5 times the value of this one Fs max, you can substitute it over here. So you can write it 0.5 times K gamma Z gamma prime Z tan delta into AS1 plus this one. For the remaining it will be K gamma prime Z critical, because it is maximum now. So Z critical into tan delta. So QS can be computed very easily. So this Z value here is from 0 to Z critical, right? So you can calculate it. For example, let's say the length of the pipe L equal to 20 meter. And diameter of the pipe is 0.5 meter. You need to, and it is C equal to 0, it is a sandy bed, and phi is 30 degree. Sandy bed. In the sandy bed, you have installed the pipe, non-cohesive. So how will you calculate this QS value? Calculate the total skin friction for this particular pipe. So how will you calculate this? The formula is known to you, 0.5 times K into S. Now you do not know Z critical. So how will you calculate the value of Z critical? Z critical is not known. So this Z critical has to be calculated. So it's a function of relative density is given by Vesic. This critical depth is the function of relative density. So if relative density is less than equal to 30%, this critical depth equal to 10 times the pile diameter. And if critical depth is greater than equal to 70% for dense ground, this is loose ground, this is for dense ground, the critical depth as per Vesic is 30 times T. For in between values, say it is 50%, you can go for linear interpolation for calculating the Z critical. Now let's say for your bed, the value is 30%. It is a loose ground. So in a loose ground, the relative density is 30%. So here I give you relative density equal to 30%. Then, because the relative density is 30%, Z critical will be 10 into 0.5, that is 5 meter. So your Z critical can be computed, this becomes 5 meter. And what is the total length of the pipe? 20 meter. So remaining 15 meter, L minus Z critical equal to 15 meter. Total length of the pipe becomes 20 meter. And this is the variation of the unit skin friction. So how we are going to calculate this one? So let's see that. So QS1, that is up to Z critical, will be given by 0.5, and the value of K is given, it is always given for loose ground. Let's say K equal to 1. So K is 1. Gamma prime is the property of the ground. So let's say gamma prime is given to you as 10 kilonewton per cubic meter, the unit, effective unit weight. So you need to multiply it by 10. Now, here up to 5 meter for Z equal to 5 meter, right? So here Z value is going to be 5 meter because it is linearly varying up to this into tan delta. Tan delta is going to be 2/3 of 5 because it is loose. So 2/3 of 30 degree. That means delta becomes 20 degree. So your first term is going to be like this, up to 5 meter. For Z, up to 5 meter. Okay? And then beyond 5 meter up to 15 meter, the second term you can write it. K equal to 1, gamma prime is already known to you, 10 kilonewton per cubic meter. Z critical, how much it is? This has to be multiplied by the ES1. So multiply with this quantity multiplied by the shaft area. So what will be the shaft area up to Z critical? It will be pi d into up to Z critical. So pi d is the perimeter into Z critical will be AS1. So D you substitute it 0.5 meter and Z critical is 5 meter. So substitute the values, you get the first term. The second term is K gamma prime Z critical tan delta multiplied by the shaft area beyond Z critical. So plus here K is 1, gamma prime 10, Z critical is 5 meter into tan of 20 degree into AS2. Now what is the surface area? Surface area has to be considered beyond this. So it will be pi into D into what is the length? L minus Z critical. So L minus Z critical, you substitute it. What is L minus Z critical? It is 15 meter. So this becomes 15 meter. So here it is 5, here it is 15. So and Fs max is going to be Z critical here 5, here up to Z critical 5. So this formula is to be used for computing QS1 and this becomes QS2. So the total, if you add up, this becomes QS. So total skin friction equal to QS1 plus QS2. So QS1 plus QS2 will give you, this formula has been used to compute the total skin friction. So this is the way you can compute the total skin friction. So we have tried to make you understand with the help of this. So you can't use the property of the cohesive bed. Here it is non-cohesive, therefore C will be 0. Phi has to be taken into consideration, and this is how the unit skin friction can be calculated. Now, how to calculate the unit end bearing? So, in order to calculate the unit end bearing, you have a formula given by Vesic research paper. He gave the value of QE. So QE equal to 3 times Q and Q. This is the expression. The Q is the surcharge at pile stick. So you can calculate the surcharge at the pile stick. NQ is bearing capacity factor for the foundation. This will be given to you, NQ. This you can calculate it here. The value of surcharge. The value of surcharge, Q will be, what is the unit weight? So if you know the unit weight multiplied by the value of the total depth up to this level, that will become the surcharge. So surcharge can be computed, NQ, bearing capacity factor. So you know QE value, and he has given the formula for NQ. So that the basic formula for NQ can be used. NQ, the bearing capacity factor equal to E raised to 3.8 phi tan phi multiplied by tan square 45 plus phi by 2. So this expression you can calculate. Say phi equal to 30 degree, you can substitute, you can convert it into radian, multiplied by 3.8, multiplied with tan phi, and e raised to that value into tan square 45 plus phi by 2 will give you the value of NQ. Substitute it, substitute the value of surcharge, and you get QE. So as per Vesic, this expression is widely used. Once you know the value of QE, then the load transferred at the pile step, capital QE equal to unit end bearing resistance multiplied by area of the piles at its end. So therefore, you can already you know QE, and this will be, depending if it is a circular cross sectional pi, this will be pi by 4 d square. So from geometry you can find out this. This you have already found out. Hence you can calculate this, and therefore the ultimate load carrying capacity can be calculated as US plus Q. So there is a simple way of calculating this. There is a IS code formula also that I will be talking in the next video. Thank you very much.